Hello everyone. I'm Krishna. I belong to FBOSS agent team, and we'll be talking about our experience in onboarding a new silicon vendor into Meta's fleet. Here's a, as I said, we're going to talk about the experience in three different perspectives. One from through hardware, through software, as well as from the vendor perspective on onboarding a new ASIC. So this ASIC is I think we introduced this ASIC in the yesterday's keynote, which is about Wedge 400C. This is a new platform which is based on Cisco. That was another top of the rack switch.
Please talk into the mic.
Okay, sure. I'll let George take over to talk about his experience on the onboarding the hardware.
Hi everyone, my name is George Carrillo, and I was a lead hardware engineer on the Wedge 400C. And as you can see, if you look at this from the outside, you can't really tell any difference between Wedge 400C and Wedge 400. And you look at the inside, it looks pretty much the same. Sorry about that. Similar function, all the functionality is 100% compatible. And just to give you an idea, here's the overview of the block diagram. If you would go to the switching ASIC and put in Tomahawk 3, you wouldn't know the difference between this and the Wedge 400. Hardware-wise, we have the, from the outside it looks identical. It has exactly the same features as the Wedge 400. This is the slide I really wanted to get to, the journey. The journey started probably, in the spring of 2019 with Cisco giving a really excellent presentation and a detailed view of what the Gibraltar ASIC functionality is in architecture. The ODM engagement was with Celestica. It started in probably late April, early May, and I just want to give a shout out to Celestica. They've been an outstanding ODM from the design phase through execution and manufacturing. A really, really great partner there. Okay, so EVT, basically, the kickoff was in Shanghai, and the Cisco team traveled with the Meta team for the kickoff. Within 2 or 3 months, we had hardware in the lab in Shanghai, and the Cisco team again came with the Meta team and worked with the Celestica ODM and brought up the card. It was really smooth. I think we had traffic running in a day or so. Really great. And that gets to the next point. For onboarding a second silicon ASIC is no easy feat, and Cisco has been an excellent partner. They've really been with us every step of the way, and they continue to be an excellent partner. They were there on site with us, and with any issue, they're I would say 24/7, they're with us here. We had relatively few issues during the EVT phase and DVT. We actually, the only reason we spun the card in the DVT phase was to design out some end-of-life components. Other than that, the hardware manufactured through DVT, PVT, and we hit MP in June of this year. And I'll turn it over to my FBOSS colleague.
Okay, thanks, George. I think I'm going to talk about from the software perspective on how challenging and fun it was to onboard a new ASIC. Let's dig deeper. So what's FBOSS? FBOSS is our Facebook open switching system, which is responsible for controlling the networking switches in our fleet. Also, I'm proud to say this is one of the largest services in Meta in terms of the number of instances deployed. This provides an overview of how our software interacts with the vendor. So just a quick grasp here, software switch is which is completely hardware independent, which interacts with the monitoring daemons, the protocol daemons in everyone outside, and program every data back to the hardware switch. So we have 2 layers of hardware switch here. One is called the BCM switch, which is very tightly coupled to the Broadcom SDK. And we have ASIC switch, which is our new implementation, which we're moving forward with, which is ASIC based. So as you can see, with SI implementation, we are trying to onboard more vendors here. So how did SI help us here? Like, so let's go a little bit deeper about what SI. SI is a switch abstraction interface, which is a project under OCP, which provides open source APIs to control the forwarding elements, and also which is vendor independent. So the FBOSS SI-based implementation is used for, as I mentioned in the previous slide, is for the hardware switch to onboard multiple ASICs. So we don't need to, from the agent point of view, we don't need to port any of the code to run it across different vendors. It's also easy to onboard newer ASICs. And we've also made open source contributions. Right now, FBOSS code is completely open sourced, as well as we have contributed to ASIC spec as well. So this is the perspective of how we onboard a newer vendor. So there are two perspectives from the software. One is from the vendor angle and one from the Meta's angle. So we didn't get to this in day one, but this it happened over a few iterations. Let's go over the vendor perspective, right? So what happened was, like, vendor builds the FBOSS, in this case Cisco builds the agent and the test cases. Then they run the hardware test cases or any test cases from our side and the benchmarks, and then they cut out a release for us. From the Meta's perspective, like these things happen in parallel. So as vendor develop their features, we also develop our SI switch implementation from our side, get the SDK integration from the vendor, and these two happened in a cycle. Alongside, when you want to onboard a new vendor, so what's going to happen is, like, there are other tooling that has to be updated. As I said, like, so one of them is like the hardware test cases, which I think we'll dig about every component here. So the hardware test case, which has to be ported, and then post tooling here is a big bucket, which covers all the way from provisioning, operational effort like monitors and alerts, and then finally all the way to get to the fleet. And also we go through, as George mentioned, we go through like several phases of testing, like EVD, DVT, where like we do our feature testing, we do our rack testing with different rack types before getting into deployment. The first one is like the SDK integration itself. So initially there were hurdles to integrate Cisco's SDK because of the difference in tool chains between us and Cisco. But then it came over, like, so initially, like, as I said, like, it was like a month to integrate an SDK, but right now to onboard a newer SDK, it takes like a couple of days to push it to the fleet. Cisco also had a release cadence of 2 weeks, which helped us to achieve a parity. So how would we validate functionality in the software today? So before jumping in there, like, we have another model to test it out today, which is called a single box data plane testing. What it does today is, like, we don't use the external entities or any XIA or any host to test it out for continuous testing. So what we do is, like, we use the ASIC to be put in the loopback mode, and then we do run several test cases on top of it to ensure that the functionality is working fine. So as you can see, what we did was the initial test cases were all very vendor dependent. We ported all these test cases in a vendor agnostic format so that it can be run on all SI as well as non-SI platforms. And today we have like close to 2,000 test cases, including Wormport, which is run on several platforms. This also helped us to validate every functionality like ECMP, COS, and any forwarding functionality can be validated using this model. So how did open sourcing help there to achieve working with vendors? So as I said, like, so Cisco was very accommodative in this case. Like, so they picked up the open source right away. They started building the FBOSS and started running the test cases from day one, which helped us catch regressions from day one. So it wasn't like we have to do the integration and then catch the issues. So Cisco were catching the issues pretty early since they picked up in the open source. And also, I think they ensured that before cutting out a release, they ensured that these test case and results are published. As I mentioned, tooling is a big bucket. So onboarding a new ASIC is not just FBOSS integration and the SDK integration. So every part of tooling and Meta has to be updated to onboard a new ASIC. So the push tooling is something which, as I said, like, you have to starts from provisioning all the way to deployment. So that has to be updated with respect to tooling. The kernel modules, of course, to send and receive packets. That has to be different for every platform. There's also these chip-specific configurations that has to be different, like the generation of these swaps and the SERDES values. I think those things has to be different for different platforms. And finally, the test infrastructure itself. Since to accommodate a newer platform in our test framework, we need to go and update like every tooling there to accommodate a newer platform. Lastly, the SI challenges with respect to software. Since we were using different vendors, it was hard to force a vendor to use a particular SI version because they were in their own SI versions, and that was causing a lot of issues for us. So the model which we followed today was to use the header files or the SI versions provided by the vendor itself. So rather than we using our own version, we are just relying on the vendor to provide the version we're using that. The second challenge with respect to the SI was the extensions. So we see that even though SI is completely vendor independent, there are cases where it does need some extensions for the functionalities to work. For example, LED. Some platforms provide a direct access through SI to configure the LEDs through their ASIC, whereas some need FPGAs. So the model again we use is like if it's a very generic attribute, we go with the we propose the SI community. If it's very, very specific to the vendor, we'll go with the SI extensions. With that, I'll let Willem complete from the vendor perspective.
Thank you, Krishna. My name is Waylon. I'm a Cisco Distinguished Engineer, and I'll be covering the Silicon One that's actually used in the Wedge 400C platform that it's in the Meta data center right now. So first question, I think one thing is everybody knows Cisco is a systems and a software company. I think what we'll describe here today is that Cisco is a bit more than that. And here you see that we have actually a full portfolio. And we'll describe a little bit how Cisco is actually a complete networking silicon provider. We actually have here, as shown here, 11 devices spanning from 3.2 to 25.6 terabits of bandwidth, and addressing web scale, data center, service provider applications. So it's the full range. The advantage, it's very clear that Cisco in family size, this ability to address both routing and switching applications makes clear the advantages for choosing Silicon One for the Wedge 400C platform. Here, we'll focus a little bit on the device that's actually powering the Wedge 400C. It is the Q200L, and we offer both the SI and SDK. It's the Silicon One SI and Silicon One SDK. And it's actually the same software that's actually used to program all our Silicon One devices. The Q200 family. The Q200 supports up to 12.8 terabits of bandwidth. It is P4 programmable, which means that you can continuously extend the data plane feature set. And we also support optionally deep buffers through an in-package HBM. We talked about the Silicon One device. We'll also talk about the Silicon One's software. We already have today iOS XR running over a Silicon One SDK in the Cisco 8000 series routers. We actually have more than that. We actually have other industry NOSes that's already running over Silicon One. We also have Sonic running over SI over Silicon One. And lastly, we have FBOSS running over SI, and this is running over in the Wedge 400C platform today. The journey that George talked about, I'll fill in a little more detail from the Cisco perspective. We did start with training. We also had a joint plan with the Meta team to do the hardware build. We completed the hardware build, the schematic and simulation reviews, the bring up and validation, and that sets the stage for software development. As you can see here, we were able to use continuous integration, continuous delivery to monitor the progress of our test cases, the FBOSS side test cases that Krishna described. And through the process, we were able to make sure that the SI and SDK were performing correctly in the FBOSS environment. Finally, as George mentioned, we went to production in June of this year. The Cisco Silicon One success elements I want to highlight. There were exceptional teamwork across Meta, Cisco, and Celestica, which is the ODM vendor. There's continuous issue tracking with rapid closure, and there's definitely joint world-class engineering talent to make things happen. I'll leave here that main point here that Cisco actually has a really broad portfolio of 11 networking devices addressing a wide range of applications, addressing a wide range of roles in both service provider and web scale data center environments. It is one architecture, one SDK, one forwarding code, one form factor that enables a single network and a single experience, all without compromise. With that, I will hand it back to Sri Krishna to talk about call for action.
Hey, thanks, Waylon. So the call to action here is like a couple of items on the SI spec. So one is like we have observed several times on that since I think you all know SI spec is completely enum based. So renumbering was hard because it broke warm boot for us in several times. So we want to call upon that to and also on the SI spec enhancements to expect like faster turnarounds because like having a spec pushing into the SI community itself takes a long time. So we expect to have faster turnarounds on that. Always, thank you everyone, and it's for Q&A now.
Hi. You mentioned doing the testing by putting the ports in the loopback mode. Could you tell us something more about that? For example, you mentioned ECP testing, ECMP. How do you do it in that way?
Sure. Like that's pretty much like as I said, like you put the ports in the loopback mode, and then you I don't know. I can walk through like how this happens, or I can point to the document as well. But what happens is like you put the ports in loopback mode, you configure a route, and then like you configure an ECMP, and we expect the packets to hashed equally across all the ports. I think how do you verify that? It's through the counters, and we ensure that the deviation is not very high. And that's the model. Like we have like let's say we have like 5 ports, out of which one of them is the ingress port, and the packets are originated from CPU at a high rate, which goes to the ingress port and then looks at the route, and then gets hashed to 4 different ports across, and then we'll check the deviation.
Do you make your testing framework and test cases available to the community?
The test cases, yes. Testing framework, no. So test cases are all there. I think it's up to the vendor, or I think they can enhance it to have a different framework. For us, I think we have a different framework to run these test cases automatically. But the test cases, yes, they are available. Everything is available right now in open source.
Second question is, do you have any plans to use the programmability of the data plane at Meta?
I don't know.
FBOSS and SI, it's kind of a generic data center switch.
I would think right now, no, but we'll be exploring that options soon, I would say, yeah.
1 second, we've got a question from online. Do you use the same SI that is used in Sonic for the Cisco ASIC? From my experience, Broadcom SI lacks packet handling functions and is not compatible with the FBOSS.
So we use the same SI, but we use a different model there for I think the question was for Broadcom, right?
Oh, it's just asking whether it's the same SI used in Sonic for the Cisco ASIC.
No, but I thought I heard about a Broadcom for packet handling, no?
It also mentioned Broadcom SI lacks packet handling functions not compatible with FBOSS.
Okay. Okay. So we do use the same SI. Like I said, like the version is dictated by the vendor and not by us, because as I said, like the vendors move at a different pace than we expect. So we expect the vendors to provide the version for us. That's one thing. And second thing is like, yes, Broadcom SI doesn't support today or lacks certain functionalities for the packet handling. So, and FBOSS expects these packets to be callbacks. So what we did was we implemented those things ourselves in the Broadcom SI layer. So the way we do is since we expect callbacks, so we implemented that callback layer on top of Broadcom SI to handle these situations.
Thanks.
Correct me if I'm wrong, but I think it's the first time that Facebook is using two switch ASIC vendors in a single product. Given this step, should we expect that in the future you may consider using 3 different vendors?
Yes, I think the idea of moving to SI is yes, to open up for new possibilities, yes.
So this is probably a question for Cisco. This might, you don't use SI internally, you're only using it for either FBOSS or Sonic with your customers. What are the challenges like associated with keeping up between like what you can do natively and what you do on SI? And any thoughts of dog fooding programs of SI within Cisco to help with that?
Yeah, that's a good question. So I'll also address a little bit of the earlier question that we do use the same SI for Sonic and FBOSS. I think that's a question that was asked earlier. In terms of consuming SI in other environments, in other NOS environments, we're perfectly open to that concept idea and to accelerate perhaps more developments in SI. We actually do also contribute to SI. So I think perhaps there are features that we see in other NOSes that are potentially useful, and I think that's an area that where we can also contribute to SI and sort of maintain the same level of feature set. That's definitely under consideration. Thanks.
We had another question from online, which is great. How much of your overall testing are you able to cover through loopback testing versus using external tools?
At least the forwarding perspective, I think pretty much all of it, I would say. We are trying to explore other options as well by using external tools, but right now the model which we have is like pretty much all forwarding functionalities is tested using our loopback testing.
All right. Any other questions? Let's thank speakers. Thank you.
Cool, thanks.